Hello everyone, my name is Jeevan. Today I'm going to explain the very important concept in term of network security domain, uh, or that is useful for every communication uh, over the internet or in LAN or anywhere. If there is communication between two computer, so this transmission, the MTU and MSS play a very big role. So we need to understand how the packets, the data transfer from one computer to another computer all the way actually. So the M that is less that depends. Here I'm trying to show this computer are connected directly with the ether cable, but this behavior, the concept will remain same whether they are directly connected with cable, I mean wired or uh, wireless, because the N the media it has to travel somehow in the Wi-Fi somewhere here to all the way to your switches to all the way down and then to your another system. So this system can be two computer or maybe one maybe server and another maybe client. But we need to understand the communication flow and what is the maximum data size can go over this wire or wired. So how this communication go, there is a concept, the OSI layer. So this packet flow from this system to the far end go in a seven layer of the OSI. That's the logical layers defined to understand how the traffic flow. So all the way from top to bottom. So bottom layer is like a physical layer, which is your cable in case or your wireless system. So then top of it, we have a data link layer. That's the data link layer where you have the frame, the packet frame unit of your packet goes here to there. So this is in the data link layer, the maximum. This is you can say this is the capability of this cable to carry as a one single frame of uh, packets including the payload and the any headers, tail, and any additional marking there. So this is the maximum thing can go. So the MTU is the maximum transmission unit of your wire, and the MSS is a maximum segment size. So segment comes in a uh, above transport layer, this packet size. In the network layer, the payload is called the packet size, and here it is called segment. In the data link layer, it's called a frame. So the frame, so every layer, the maximum and finally at the last, the traffic needs to go on this wire. So this wire can handle the maximum MTU is 1500 bytes of payload plus it can handle 18 bytes of the Ethernet headers. So the total MTU on the wire can be 1580 18 1518 bytes, including the Ethernet headers. So Ethernet header goes around 18 or sometimes 20 bytes, uh, but the remaining, the real payload can be of 15 bytes. So when this goes to the next layer, network layer, so network every layer adds their header information. So in header, what is in header? It's another very detailed topic. I can prepare a separate video on this to explain what is in TCP header, what is in IP header, and and all. So for now, you can just understand that header is just like a tagging some information in the network layer. It is going to be the source and destination IP address and couple of more information. So this information itself can go up to 20 bytes. So that is reserved for this header information. So now you are left with 1500 minus 20, it's 1480 bytes on the network layer you can have, provided there is no other encapsulation or anything there. Then when it goes to up in the transport layer, so there then transport layer, the TCP header size is again 20 byte. So what is in TCP header? The TCP header contains the information about the source port and destination port, or TCP connection number, windowing, and all these checksums and all. So that will contain up to 20 bytes of space, and then remaining 1480 minus 20 will be 1460 bytes of your real payload. So this is your maximum segment size, meaning the real payload, the real packet, the data that you are sending, that can be go in a one shot. But now you may have a question, because let's say we are sending 2 GB of data, copying one file from here to there, or 2 GB, or maybe 1 MB, but that's 2 MB, then how that goes? If this pipe can contain only maximum 1580 bytes of the data, then how that goes? Yeah, that may you may have this question. So in this communication, this transmission happen in a segments. So this is the one shot moving data, transmitting from here to there. But let's say you have a 2 MB of the data transfer from here to there, then the total 2 MB will be broken into multiple parts, equal parts of the size, which will be fitting in this MTU units. So in every parts cannot go beyond this, and then it will be equally divided in n number of parts of your total data transfer. And if whatever minimum left, so that will go in a last one. Let's say last one, you have a 10 equal packets of 1580 1500 byte, and the remaining left 20 bytes. So the last packet will go for will carry just for this 20 bytes, along with the uh, tail and header information of every layer. So this is how the traffic goes all the way from one place to another place. The MSS is a maximum segment size. The packet when goes, so the header information is there, so that minus that header information, and that is the maximum size you can say this media can take further. So in reality, in each packet, so if there is a no customization, so the maximum packet the payload can travel is 1460, because this is the transport layer. But then if it goes down, then network is going to add another 20 bytes, so then we need a space for it, and then uh, data link also has their checksums and all. So the real can maximum size can be this. So why I'm talking about this MSS bit, why that is very important to understand, because if you have some restriction, or you are saying this client or this server, and if they say, hey, do not fragment this big packet, or do not break it in parts, and they have to agree on what is the maximum segment size they want to use to make the communication. That is part of the TCP handshake process, three-way handshake. The three-way handshake is a very detailed concept, and I can, uh, if you want, you can put that in comments, so I can prepare another video on this topic separately. But for now, the TCP three-way handshake, when two machines perform, two client, server and client perform to start sending uh, real data, so they agree on this MSS value. So why they need to agree? Because they need to agree and understand what is their that far end capability. Because let's say I send very big packet from here, but this path or this guy is not able to handle that packet, and that will be there will be a lot of discards, or they may not able to reassemble it at the far end properly, so the communication will fail. So for this reason, for in every TCP communication, uh, the nodes, the client and server needs to agree on this MSS size when before sending the data when they perform the TCP three-way handshake. So that's why it's very important to understand and the role of MSS will be there. And that's it for now in this context. If this has been informative, please consider subscribing my channel. And if you want to see any specific video in a specific topic, so please mention that in comments so I can try to prepare to fulfill your requirement. Thank you.